Hello everyone, and welcome to our first digital learning lesson. It might be a little shaky at first, but I know that we will get better at this as we go along. So your feedback is crucial to this process and letting me know, hey Ms. Bartlett, these videos are going too fast, or maybe you could do more examples. You're going to have to help me create this virtual learning lesson scenario for you. So let's get started. One of the things that we're working on is starting out the lesson with an I can statement. This I can statement basically says I can or I should be able to do this by the end of the lesson or by the end of the practice. So it's sort of a self-check, like, can I do that? Because it is sort of our expectation. So let's get started with our I can statement for today. I can simplify a square root. And this is actually a concept that I believe you worked on in Algebra 1, which I know seems probably forever ago. So we're just going to touch on it, and that's where we're going to begin this unit. So here we go. I can simplify a square root. So let's talk about just a second the pieces of the square root and what they are. So the square root symbol looks like this. It's got this little kind of dip on here. It goes up and over. This little dip here is actually pretty important. If you didn't have that there, it would just look like a long division symbol, which is not what we're doing. So you want to make sure you want to make that little line there. I'm sure it has a name for it, but I'm not sure what it is. So there is the square root symbol, and where it comes from is an actual square. So let's talk about squares for just a minute. We'll look at a couple of them. So, as you know, a square is a figure with all of the same sides that measure the same. That's just, I didn't do very good there. Okay, so if this has a side of 2, well then the length and the width is 2 and 2. And if I were looking for the area of the square, I would use length times width. So 2 times 2. The area of this square is 4. Similar, if I took another little bit larger square, if I had a 5 by 5, 5 times 5, the area of the square would be 25. So this is where we get your perfect square numbers. So let's make that list of perfect squares off to the side here. So I want to mention, as I'm writing this, as you're watching this video, you should be also writing these same things down into your notebook or on a piece of paper that you keep in a binder. In the traditional classroom, if we were face-to-face, I would have you write this in your notebook, and then I would do a notebook check on test days to make sure that you had all of the content. What we're creating here is our very own reference book or textbook for the course that we'll refer to when we're studying or preparing for a quiz or test. Also, think about it, if you're at home, you can use this as a resource if you have an online quiz or an online test. So everything is open book, but you don't necessarily have a book at home while you're creating your own. So please write this down. So your perfect squares, you have 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8. Oops. I said 8 and I wanted to write 8. It's interesting what your brain does sometimes. 8 times 8 is 64. 9 times 9. 10 times 10. 11 times 11. And 12 times 12. There are obviously more pairs, but I'm going to stop right at 144. You can look up as many as you want to in your free time. So, looking at all these perfect squares, what this means is that when I take the square root of a perfect square, say like 25, basically what we're answering the question is, if I have the square with an area of 25, what would be the side length? So I'll show you two different methods to simplifying a square root. The first is to look for the highest perfect square number that goes into your radicand. I'm not used to these touch screens, these dots here. So since 25 is on my list, I know that it is 5 times 5. So we're going to make this little tree here. 25 is broken into 5 times 5. This is called prime factorization. So what we'll do, I have a 5 and a 5. Square root is looking for pairs of numbers. You are looking for a pair of numbers that are the same number. So I'm looking for things like 5 and 5, 4 and 4, 3 and 3, because again, we're talking about that square and the two side lengths that are the same. So a pair of numbers. In this instance, I have a 5 and a 5. Only one of them, only one from the pair comes out. So the answer here, if I take the square root of 25, which I broke into 5 times 5, the answer is going to be just one of the 5s. So we're really only looking for what is that one side of the square, because they're all the same. All right, so let's practice this for just a second. I'll do another one. If I were to take the square root of, let's say, 16. So 16, again, is on my list of perfect squares. 16 is 4 times 4. So I'll break 16 into the pieces. 16 is 4 times 4. And then I realize those aren't prime factors, but this will be one of our approaches to simplifying this. I have a pair of numbers with nothing left over. And I have 1 4 here and 1 4 here. Only one of them comes out. as my answer. So I'm going to let you practice that for just a minute and see how things go, just to kind of refresh you on the perfect squares. So try these. Let's do the square root of 9. $49 and 81. So I'd like you to pause this video and practice these items for just a moment. All right, so you can see my work. Hopefully you are feeling the same way. Please check the next video for what happens when it's not a perfect square value.